So as we can see here in this video, we are going to solve the recurrence of Tower of Hanoi for the complexity questions in the design and analysis of algorithm. And in this video, we are going to solve using the substitution method. So we will solve using the substitution method. So in this, first we are given t of n is equal to 2 of tn minus 1 plus 1 and t of 1 is equal to 1. Now here, if we want to understand this recurrence, this 2 of tn minus 1 stands for the 2 times we shift the disk from the source to the sphere one time, and then from sphere to the destination n minus 1 disks are shifted. So this is the effort of those n minus 1 disks, and the largest disk is one step, so that one step is added here. This is how we can explain the recurrence of the Tower of Hanoi. Now for solving using the substitution method, what we will do is, we have given what is t of n. Now let us find out what is t of n minus 1. So now t of n minus 1 will be 2 of t n minus 2 plus 1. So we mark this as equation 2, and what is given to us, that one is the equation 1. This one is the equation 1. Now we put this 2 into 1, put equation 2 into 1. So what we will get it, 2 is outside, then instead of t of n minus 1, we will write 2 times of t n minus 2, and then we will write plus 1, this plus 1, and then outside the bracket the remaining part of this, which is plus 1. Now when we open this bracket, it will become 2 square t n minus 2, this is t n minus 2 plus 2 plus 1. Next time we will substitute for t of n minus 2, as we will see here. So as we can see here, it is t of n minus 2 is equal to 2 of t n minus 3 plus 1. Now we put this thing over here instead of t of n minus 2. So what we will get? So when we put the value of t of n minus 2, which is this value, into this third equation, say this one is third, and the value of t n by 2 is fourth equation. So when we put 4 in 3, we will get something of this kind, 2 square into 2 times of t of n minus 3 plus 1, and outside the bracket plus 2 plus 1. Now when we open this bracket, this will become, so now when we open the bracket, it becomes 2 square into 2, 2 cube plus into t of n minus 3, then this 1 gets multiplied with the 2 square, so 2 square plus 2 plus 1. So now if we look at this very closely, what we are going to get is, if let us say we put I is equal to 3 in this particular equation, we will generalize this equation. We get 2 raised to the power of I t of n minus I plus 2 raised to the power of I minus 1 till 2 raised to the power of 0, which is 1. Now when we look at this, what we can do is for this much portion, after we have generalized with I, now we have to put such a value of n minus I so that we get t of 1, and that value of I will be I is equal to n minus 1. So when we put this here, we get 2 raised to the power of n minus 1. Then t, n minus 1 plus 1 will give us t of 1. And then we have this I minus 1 is there. So this will become I minus 2 raised to the power of n minus 2. And the whole series will be there. Now when we look at this one, we can write this as using the GP formula. We can write this as 2 raised to the power of n minus 1 upon 2 minus 1, which is 1 only, plus t of 1 is 1, which is given to us here. T of 1 is equal to 1. So t of n minus 1. 2 of n minus 1 is there. So when we add these two, it will become 2 times of 2 multiplied by 2 raised to the power of n minus 1 minus 1. Now if we look here, bases are same, powers can be added. So this 2 will be absorbed here with a plus 1 here. And then minus 1 and plus 1 will get cancelled. So what we are left with is 2 raised to the power of n minus 1, which is the complexity of tower of Hanoi. So you can see here we have solved it in a previous video using the recurrence tree, and here we have solved it using the substitution method. I hope this video is useful to you. Thank you very much.